In this video, we'll be looking at partial fractions. So, what the heck is a partial fraction? Basically, partial fractions are a fancy name for undoing addition of fractions, starting with the common denominator and breaking it into two or more fractions that do not have common denominators. So let's start with the fraction 3x minus 3 over x plus 1 times x minus 2. We want to break this up into two different fractions. The denominator of each fraction will be one of the factors of the original denominator. Let's begin by writing the original fraction. This is going to equal some number over x plus 1 plus some number over x minus 2. So all we did was to break up denominator. Sometimes this may be given to you in unfactored form, such as x squared is x minus 2 as the denominator. If this happens, you'll have to factor the denominator. But in this case, it was given to us factored, and what we want to find is some numbers that we can substitute for a and b in the numerator. When we're dealing with fractions, we want to multiply the fractions by the common denominator so that we can cancel out the denominator. The common denominator in this case is x plus 1 times x minus 2. So when we are multiplying through, we multiply by the parts that are missing from each denominator. For the first one, it'd be x minus 2 over x minus 2, and the second one is x plus 1 over x plus 1. We can do this because we are multiplying through by 1. Then we need to multiply both sides of the equation by x plus 1 times x minus 2. What we are doing is canceling the denominator all the way across. And what we are left with is 3x minus 3 equals a times x minus 2 plus b times x plus 1. Now we're going to use a little trick to figure out what a and b are equal to. We're going to pick some numbers for x. The first number we will pick will be a number such that a will be multiplied by 0. So what we're going to say is that if x equals 2, then what we have is 3 times 2 minus 3 equals a times 2 minus 2 plus b times 2 plus 1. On the left-hand side, we get 6 minus 3 equals 3. And on the right-hand side, we have a times 0. The a is gone, and then we'll give b times 3, or 3b. We'll divide through by 3, so b is equal to 1. Now we go back and pick another number for x, such that b will be multiplied by 0. So we'll say that if x equals negative 1, then have is 3 times negative 1 minus 3 equals a times negative 1 minus 2, and then the b is multiplied by 0, so it's no longer in the picture. So we'll get negative 3 minus 3 equals a times negative 3, negative 6 equals negative 3a, and divide through by negative 3, and we'll get a is equal to 2. So clearing up a bit, what we had was a equals 2 and b equals 1. So the answer to this is 2 over x plus 1 plus 1 over x minus 2. That's the partial fraction, and we've now broken up the original fraction into two fractions. We're going to now check this to make sure. In order to check a fraction, if we're adding, we would need to find a common denominator. It would be x plus 1, x minus 2. we'd multiply the left-hand fraction by x minus 2 over x minus 2. The right-hand fraction x times x plus 1 over x plus 1. Using distributive property, we'd get 2 times x minus 4 plus x plus 1 over x plus 1 times x minus 2. 2x plus x is 3x, negative 4 plus 1 is negative 3 over x plus 1 times x plus minus 2, which was our original fraction. Completing the check. There's a special rule when we have a repeated zero, such as the x plus 2 in this fraction. We'll need to write the partial fraction as 3 parts with an a, b, and a c. We'll start with a over x minus 3 plus b over x plus 2, and then our c will be c over x plus 2 squared. Now we need to get rid of the denominators, so we'll multiply everything through by x minus 3 times x plus 2 squared, and we'll end up with 3x squared plus 4x plus 11 is equal to a times x plus 2 squared, the missing parts from the denominator, plus b times x minus 3 times x plus 2 plus c times x minus 3. What we need to do now is to find the values for a, b, and c. So we're going to start by picking some values for x so that we can isolate the a, the b, and the c. Let's start with saying that if x equals negative 2, then we would have 3 times negative 2 squared, which is 4, plus 4 times negative 2, which is negative 8, plus 11 is equal to a times negative 2 plus 2 squared, which is 0, so the a disappears, plus, in this case, the b will also disappear, or be multiplied by 0, and we're left with c times negative 2 minus 3. So we get 12 plus negative 8 plus 11 equals negative 5c. On the left-hand side, we get 15 equals negative 5c. Dividing through by negative 5, we get c equals negative 3. Now we solved for c by choosing our x to be negative 2. So let's go back. We want to find a value for a or b. So let's let x be equal to 3 so that in the c will be multiplied by 0. So if x is equal to 3, now we want to go back to the original left-hand side of the equation, and we will get 3 times x squared, 3 times 3 squared is 9, plus 4 times 3 is 12, plus 11 equals a times 3 plus 2, which is 5 squared, is 25, plus on the b, we have 3 minus 3, so it's going to be 0, and the b is gone, and the c is gone because we have 3 minus 3. So we are eliminating it down to just the a. So we'll get 27 plus 12 plus 11 equals 25a. So 50 is equal to 25a, dividing through by 25, and we'll get a is equal to 2. So now we've solved for c, we've solved for a, we need to solve for b. So let's clear this out a little bit and get a cleaner board. We know that a is equal to 2, c is equal to negative 3, and when we divide through by our common denominator, this is the basic formula that we have. So what we need to do is to pick a different value for x. We want to pick something simple, so we can pick 0 or 1, and we'll multiply through. Let's pick 0. So if fx is equal to 0, then the 3x squared will be 0, plus 4x will be 0. We're left with 11 is equal to a times 0 plus 2 is 2, but 2 squared is 4, but we know that the a is 2, so it's going to be 4 times 2, plus b times 0 minus 3 is negative 3, times 0 plus 2 is 2, plus c, which we know is negative 3, times 0 minus 3 is negative 3. Now all we have to do is multiply through to find what our b is. So 11 equals 8 plus negative 6b plus 9. Subtracting 8 and 9 from both sides will give us negative 6 equals negative 6b. Dividing through by negative 6, b is equal to 1. And now we have solved for a, b, and c. So the answer to the entire equation is not a equals 2, b equals 1, c equals negative 3. The answer is 2 over x minus 3 plus 1 over x plus 2 plus negative 3 or minus 3 over x plus 2 squared. We'll have a chance to practice these in class, and we'll continue the topic of partial fractions in the next video. And now, just for fun, remember, 5 out of 4 people can't do fractions. See you in class.